Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, it's the start of a Commodore 64 Repair-a-thon. It's been quite a while since I have done any of these. All of these 64s were sent in or donated by viewers, and let's try to fix them. So without further ado, let's get right to it. Before I get started on the Repair-a-thon, I want to talk about what I'm going to be using to do the testing on these machines. I'll preface that by saying you don't need to have all of these things to successfully fix a Commodore 64, but it definitely helps and it speeds up the process. So right off the bat, the thing that helps me the most is to have a working Commodore 64. So this here is my ZIF64, which I think if you watched any of my Commodore 64 videos before, you're familiar with this. It's just a bread bin where I've replaced most of the sockets with ZIF sockets or zero insertion force sockets. It just makes it very easy to take chips in and out of this machine. So if I have another Commodore 64 that might have a bad, insert a particular chip, I can take it out of this, which is a known good machine, and test it in the other machine, or I can take the chip out of the other machine and stick it in here to see if that chip is the problem. This is the single most useful thing to me for troubleshooting Commodore 64s. Next is my dead test / diagnostic cartridge. This is a cartridge you plug in the 64 and it has both the dead test and the diagnostics, which you set these dip switches to configure which one you're going to use. Dead test can be helpful in some circumstances to figure out if the machine has some signs of life, but maybe has a bad RAM chip, but it's not always accurate. It might say it has bad RAM and it's actually something else that's wrong, but it's a good test to say that there is something going on with the machine versus nothing. Next up is my Rigol oscilloscope. I use a 1054Z. There's a test probe right here. We may or may not use this in this video. It just depends on what's wrong with these machines. Then I have this bag here, which is full of that lovely 70s carpet. And inside here are things that were all donated by Stuart, one of my viewers. So there's a logic pulsar, there is a current tracer, and there is also a logic probe in here. So I haven't really shown me using these on the channels because I haven't had an opportunity to use these. So hopefully we'll have some opportunities to use some of these in diagnosing these machines. These HP test instruments are pretty rare and kind of expensive these days, so don't worry, you can actually just use something like this, which is an inexpensive logic probe that I bought off eBay a while back. And this still is very useful, especially if you don't have an oscilloscope. This can give you some good insight into potentially bad signals on a chip or floating signals, things like that. That's what these are good for, even without having an oscilloscope. Then I have this jumble of wires and connectors. This is the test harness. So this is only useful once the machine is up and running, like it is here. And then you would put the diagnostic cartridge in, which is one of the two ROM images on here, with this plugged in, and it goes through and tests all the ports, keyboard port, joystick ports, user ports, cassette port, because this can identify faults that may not show up. Like you might have a machine that looks like it's working like this, but it turns out that the cassette port doesn't work. And the test harness helps you figure that out. And of course, it goes without saying, you need to have a working monitor, which is an LCD, in this case, hooked up to the retro tank, which is back there. I think everyone on the channel has seen this, but you can use anything that has a composite input. Just make sure you test it, that it works before you start troubleshooting your 64, because you don't want to be in a situation where the machine is actually working, but there's something going on with your monitor or your cabling that is preventing it from working. So you just need to double check that you have something that fully works before you go down the wrong path. And with that, it is time to start troubleshooting the other 64. So I'm going to move my ZIF one out of the way, and we're going to start on machine number 1. So I have no idea how many videos this is going to be because I honestly haven't really done much troubleshooting on this machine, so I don't know what the problems are going to be. They might all require only simple fixes, or they may have bigger problems that are going to require more troubleshooting with this other stuff that will take me longer. All right, so the first machine here, and it's pretty beat up. It's very yellowed on the top, it's got missing keys, extreme yellowing on the keys. And I have a note here that I did stick on it. It says mail call Mike. So Mike donated this machine, thank you Mike. It says black screen, dead test okay, but with corruption. Let's pop this machine open and we'll take a look and see what we see inside. Maybe there's obvious issues with it. All right, looks like I've been inside here because the keyboard was already disconnected. All right, right off the bat, I'll move the LED here. We can tell that this is the very first rev of the Commodore 64 here in North America. This only has the 5-pin video output here, so no chroma and luma. I have found these machines to be quite reliable as a whole. It seems like Commodore, the MOS fab that was making these chips early on, were a little more reliable than the ones from like 83 and 84. Those seem to be the most unreliable from the bread bins. And then the later 64C type are more reliable again. There was like a period of a few years in there where they're extra unreliable. And these early ones, pretty reliable. So, observation time. The SID is already missing on here. I'm pretty sure that was taken out before I got to this machine. Next up is the PLA is an actual Signetics 82S100. This is one of the original chips that Commodore bought from Signetics and actually programmed. So this was not even made by Commodore. These chips run hot, but they're extremely reliable. So almost certainly this PLA is not faulty, although it's worth checking. Looking at these other chips here, the date codes are all very, very early 1983. So second week of 83, second week, fourth week of 83, and so on. I am seeing quite a lot of corrosion on this board. There's definitely some crusties on some of these ICs here, like that leg there looks rusty of all things. And the RF modulator here is also a bit rusty, but overall this thing is in pretty good shape. So first thing I'm going to do is I am just going to remove all of the ICs from this board that I can, and we'll run the dead test diagnostic with them out. Dead test does not require to have the ROM chips or these two 6526s in here. And of course, it's quite possible that a chip could be malfunctioning to the point where just having it in the machine can cause issues. It can cause corruption and like bus issues like that. I want to point out as well, I like to use this chip remover to pull chips out. It can work onto up to 40 pin chips. Problem is when they've been in there a long time, it's really good to use something like this, which is a Wiha chip lifter. Highly recommend this tool for getting ICs out. Once I've put Deoxit on these sockets, then this tool will get chips in and out perfectly. But this thing is made out of plastic. This part's metal, but the body is plastic. So you don't want to put too much stress on this, and trying to get those really stuck chips out with this thing will definitely break it. I have a link in the description to this and this tool, so if you want to buy either one of these, you can find those there. All right, all the chips are out that don't need to be in the machine for diagnosing it, but I want to take a look under here. This is where the VIC is, the graphics chip of the Commodore 64. Sometimes it's going to be pretty hard to get these off. I use this pick to get it started sometimes. And there it is. There is the VIC chip. I just want to take a quick inspection here. In fact, I'm just going to kind of look over the rest of the board. Everything looks fine on here. It's just dirty, but otherwise not too bad. All right, plug in the power. Let's plug in with a video cable. And I'm going to plug in my dead test cartridge, which means I have to configure it for 1, 4, and 6 on the dip switches, which it already is. Pop that in. Here we go. Power LED comes on the cartridge, which is what I need. And we have a video signal because the monitor woke up. Ah, there it is. Okay, it is running and with corruption. I assume that is probably what I wrote about here with this corruption. So one thing I can tell by the testing is all of the tests on the dead test actually pass. All the RAM tests are good. And that implies that the CPU is working perfectly and is able to communicate to the RAM, which also is working perfectly. But we have screen corruption here, which indicates that there's a problem with the VIC, or the VIC's ability to talk to the RAM, because it uses the same system RAM the CPU does to store the character information, and the problem might exist with that communication path. Now there is a color RAM chip that stores the color of each character, but that is actually fine because you see the red border here around here and all the blue text with the white background. There are no weird glitches with the color. If there were, I might think that the color RAM were bad, but the color RAM is not the problem. It's gotta be something with the VIC or the way the VIC talks to the RAM. Could be the PLA as well, potentially, and it's probably gonna be a logic chip is what we're gonna find. If you read troubleshooting guides for the 64, you'll find a lot of people say that, oh, your CIAs might be bad or your character generator ROM could be causing corruption like this. But the fact that they're not in this machine and it's running means that it's clearly none of these chips I've removed. It's gotta be something that's on the board now. I'm gonna pop the PLA out of here, and there's probably like a 0% chance there's anything wrong with that PLA, but just for completeness, I'm gonna pop that out. And I'm going to take another PLA, which I know works perfectly. This is actually another 82S100, which is the same as what was in here. And we'll just give this a test. Just got heatsink compound on my finger, came from this VIC here. And the problem is exactly the same. So just as I thought, it definitely was not the PLA chip. I want to clean the gunk off this Vic chip. I keep getting on my fingers, so a little 99% isopropyl alcohol. Should get most of this right off. I'm using what are these called? Cotton buds, cotton swabs, cotton balls. I want to get this chip out of here. Now, unfortunately, when you have this metal shielding around, it's really hard to get a tool like this under both sides. So what I recommend is you lift it up a little bit, then I'm going to try to use this tool here. This will fit. Oh, and it got the chip right out. Look at that. So I'd like to validate that this VIC-2 chip is working. And unfortunately, I would just stick the one from here and here, but I have my MSI heatsink on there. So what's easier is just to pop that out and to pop this one onto this board. Now keep in mind with these bread bins, the VICs from the bread bins are compatible with bread bins, and the VICs that are in the 64C shortboard machines, that's when the motherboard is smaller, those are only compatible with those machines. Do not interchange those chips. They are not compatible with each other. Here we go. Let's see if this works on this machine. And it does. It works perfectly. You may notice that the text here, I'm using a skinny font from the VIC-20. It's very fringy. You see like the colors of the red and stuff in there that shouldn't be there. That is a symptom of these types of R56A chips. That's not a fault. That is just the way they're designed. All right, so we know that this chip is good, and that's actually what I was already thinking. And we know that this PLA chip is good, and we know the CPU is good because the diagnostics are running. So those main chips are all good. And we'll put this R56A back in here. And a quick test just to make sure the machine is still working as it should. All right, good, everything is still working. So at this point, I'm confident in saying that those chips are good, and the RAM is good. The problem is going to be with some of these logic chips right here. It's got to be the issue. So what's next? Let's go to the schematics. So one thing you're going to find confusing about the 64, and I'm looking here at zimmers.net at all the schematics, is this particular board right here says 326298. That's the assembly number, Rev A. And I know just by looking at this board that this is the first revision of it. When you look at Zimmers, you're not going to find anything that says 326298 anywhere on here. Even after all this work I've done on 64s, it's still confusing to me why it's so difficult to figure out where the exact schematics for this particular board is when you look online. So I know from experience that it's 326106 that I need to look at for this version of the board. Why is it not the same as what's on here? Or why doesn't it even have a note to say that that includes this motherboard? I don't know. On the schematics, here we are with the VIC chip. Now, unfortunately, we can't scroll over any further to the left because there are two versions of page 2. But if we look at this page, which is the one we couldn't see, here are all the RAM chips. And the data lines here, data 7 through data 0, this is what talks to the CPU and on the main bus. We know everything on the main data bus is working properly because the computer is running through the entire diagnostics without any errors. But if we go back to the right-hand page and we look here at the VIC chip, it has these two chips right here, U16, which is a CD4066, and U26, which is a 74LS373. The LS373 is a latch, and it's connecting the VIC to two different address lines, not at the same time, but alternately. So the RAM chip, you can just see the edge of a RAM chip here. This is like A6, A5, A4. But this latch is allowing these other lines to be connected through to the data bus alternately, A13, A12, and so on. And now the 4066. So this chip here is also doing something with extra data lines. So we know it's an 8-bit machine and only has data lines 0 through 7, right? But notice here it has 8, 9, 10, and 11. And this chip is allowing the VIC to kind of multiplex additional data lines onto the bus. A more experienced person might recognize the symptoms that I'm having and know exactly which of these two chips is causing the fault. But it's my opinion that it's going to be one of these two that is faulty. So if we look at the motherboard here, this one here is U16. It's that IC right there. And U26 is this latch right here. I don't think the problem is going to be U16, the 4066, and that's simply because this chip also is what drives the color RAM data lines. Notice data 0 through 3 are directly connected to U16. So I feel if this chip were actually malfunctioning, I don't think the color would be set correctly on characters. So when the program tried to set a particular character to a certain color, I don't think that would get written into the color RAM properly. And that is working. We saw all the color was correct. So that leads me to U26. I'm going to desolder this from the board, and we'll see if replacing this fixes the problem. I think this board has the RF shield on the bottom, which makes desoldering the chips that much more difficult. I doubt anyone has ever taken the board out of this machine to desolder anything, because it doesn't look like the RF shield was desoldered and reattached at a later time. I'm going to be using my Hakko 301 desoldering iron here. Is it 301? Yes, it's a 301. Make sure you clean this all the time if you have one of these. And because everyone hates it when I cut away the RF shield, I am going to try to desolder it with this thing. It kind of clogs up my machine because I use so much flux on here. But I should be able to get this off without cutting it. There we go. It seems like if I just heat up the joint here with the Hakko, it's got enough thermal mass that I can get these off without cutting it. There we go. And the one right here between the two connectors is a little harder because I can't get my desoldering iron in there, but I can just heat it up. There we go, and bend it. So I think the RF shield should just fall off now. Oh, I forgot one. One more I didn't do right here, this one. There we go, the board is free. Now, even though I didn't cut this off, I won't be using this again. So I'm just going to use this to remove the excess solder. And just like I said, this has gunked up my tip here. It's full of flux and crud. All right, so if we flip this over, how does it look? It looks wonderful. Definitely no rework has ever happened on this machine. This machine is 100% original. So the IC that I want to take off is the latch, which is this one right here. So I'm just going to mark that with a Sharpie. Here we go. We're desoldering this IC. I have a video linked to in the description on my way I do the desoldering. It's a combination of using this plus hot air, and that ensures that I don't lift any traces on these old boards. So I recommend you watch that if you haven't already seen that. So there's the new socket that's installed, and here's the chip I just took out. So in case this chip's not bad, I can just put this right back in the motherboard. I'm just curious, what's gonna happen now if I try this machine without the latch installed? Dead test is still in here. Let's just see how this looks. Well, would you look at that? It looks exactly the same with the chip out as when it was in. So hopefully that's a good sign. I'm noticing the color is missing on this red line here. Everything is just the blue now. Is that good or bad? I'm not quite sure. But I think that is hopefully a good sign. So let me go find a new latch chip, pop it in the board. Here's what I found in my parts. Looks like it's from 1987 as well. So it isn't totally inappropriate from a time period. I just have to fix the bent pin and get the pins splayed correctly for these round hole sockets or milled holes or whatever they're called. Look at that, it just goes right in so easily. All right, and when we turn it on, will it work or will it still be broken? Let's see. It's gonna take a second here for dead test to wake this machine up. Oh, no fix! The color definitely came back, but otherwise this looks exactly the same, which does indicate that this original chip is not faulty. So the original 373 is back in the motherboard, and I think the next thing I'm gonna try is replacing this 4066 here. And there's the potentially bad 4066. There's a socket installed, and I have a new one that I found in my stock. Let's just straighten the pins on this, make sure everything is good. Oh, pins are a little bent. Let's do what I did last time and power this up with the chip removed. Let's just see how this looks. All right, and there it is. So the color is all screwy, which is sort of what I thought would be the case with the 4066. So I guess something else is probably happening. I have a feeling putting the new 4066 in here will not fix the data text corruption problem. New chip is in. Let's turn this on, see if this makes any difference at all. I don't think it's going to, actually. I think we're still going to have that same fault. And we do. The problem is exactly the same, just as I thought it was going to be. I have some bad troubleshooting skills going on here. So I'm taking out the new chip, and I'm going to put back in the original one. Original chip's back in. Let's just see if it still works. I want to make sure I didn't kill that chip desoldering it. I'm sure it's going to be fine. It's going to look the same, corrupted. And there it is. Yeah, it looks exactly the same. Okay, so the problem lies somewhere else, but where? I'm thinking through what the issue is, and we know it's not these two chips. I don't think it's the RAM. We know it's not the VIC. We know it's not the PLA. What could be causing this problem still? How about the CPU? So with the 6510, the way it works is to coexist with the VIC-2, this has to be able to be instructed to release the bus, basically disconnect itself from the bus so the VIC-2 can talk directly to the RAM. What if this chip is not disconnecting itself on one of the data lines that is somehow causing corruption when the VIC tries to talk to the RAM? There's an easy way to figure this out. Let's remove the CPU. Oh, it's so stuck in there. I obviously haven't taken this out yet, so I gotta pop this out. Let me first deoxit this socket because it was really holding on to that chip, and I'm gonna stick in the CPU that was in the ZIF machine, which I know fully works. And here is the CPU. Let's pop this in. Okay, there we go, it's in. Boy, it was pretty hard to push in. I put a check mark on the CPU, but that might have been an errant check mark. Let's power this up and see if the machine has come to life. Oh, no change at all. So that is definitely saying that the CPU is fine, that is not the problem. Okay, so back to the schematics. I noticed there's one more chip that's sort of hanging off of the VIC-2 here, and it's U14 74LS258. I think that's a multiplexer of some kind. And I notice here it's connected to two address lines, 7 and 6, on the VIC, and it goes off to other address lines on the machine, stuff like that. Now, let's take a look at these signals on the oscilloscope, because on this chip, on the motherboard, it's this one right here. It may not be super easy to tell on the camera, but this is the one that has very corroded looking legs. They're almost rusty. So that could be an indicator that this chip has suffered more corrosion than the rest, and maybe it's bad. Okay, so the machine is running right now. I'm gonna go down the pins on the right side, first of all. So that's VCC. Then these are just various signals, and they all look normal. I'm not seeing anything weird. I'm not really sure how this is supposed to look, but I'd say that that type of activity, that looks fine. Let's check out the other side. Okay, that pin is gonna be ground. Okay, I don't know, looks okay, I guess. That looks fine. Okay, so here we are on pin 5, and that does not look fine. It's sort of up in the middle there. Now that pin doesn't go to the VIC, it goes off to something else on the machine. I don't know where, I'd have to look on the schematics, but that definitely looks messed up. That pin looks fine. This looks good. Okay, another pin that's screwy, and that is pin 2, which also goes off somewhere else on the machine. I think this is an output pin. So that doesn't look right. And pin 1 looks fine. This looks like some kind of a clocking signal. So the fact is we have two signals that look weird on this chip here, which might indicate that it's just overall faulty. Not exactly sure what this chip does, you know, in the grand scheme of things, but clearly it's connected to the VIC on a couple lines, so it does something. And since we're having specific problems with the display on the VIC, It makes sense to look at the ICs that are connected directly to it. So I think next step is to desolder this from the board and try a different one. I think I'm kind of grasping at straws here a little bit, but the fact that there's corrosion on here and we saw those weird things on the oscilloscope kind of leads me to believe that this chip may be the culprit. New socket is installed. Here is the old chip, so that's removed. Let's try it without the chip installed. Let's see if this machine works at all with that chip out. All right, so it's clearly running the diagnostic, but clearly it's very screwed up. So that's a good sign there. In fact, let me repower cycle it, because that corruption that we just saw on the screen, it was similar to what we were seeing, just it was far worse and it was sort of changing. But with that chip out of there, yeah, look at this. Similar characters and more of them. So that's a great sign. We're actually onto something. Oh, I'm excited now. So here's the chip I found in my stock. It's old, but it's new. You know, I don't even know if these work, because a lot of times I get them, I take them out of things, or I'm given them and I don't have a way to test them. So there we go. So that chip is installed in here. Let's turn it on. Let's see what happens. Is it going to fix the problem? Oh, not fixed. Oh boy, my troubleshooting skills are garbage right now. So far, 3 chips taken out, socketed, and yet no change. Before I put this original chip back in, let's see how this new chip looks on the scope. Those pins, I think it was 2 and 5, that looked weird on the oscilloscope. Let's look at those, see if it still looks weird. So pin 2, it does look exactly the same. And pin 5 looks exactly the same as well. So one thing to consider about this chip is it is a tri-state multiplexer, I think it is, which means its outputs can be floating. So it's quite possible that those 2 outputs are just floating on this computer. And if there's no pull-up resistor on those lines, then they will look that way. And also, they're not going to any of these ICs in here. Maybe those go to some of these ICs, and without those connected, maybe that's why it looks that way as well. But either way, the fact that it looked like that was not actually a fault. So the original chip goes back in, and I am 0 for 3 on my repair attempt with this Rev-A64. There we go, the original chip is back in. Let me just turn it on. Turn off the oscilloscope, just to make sure it's still working as it was. And it is. Okay, I need to try to figure out what's next to try to solve this issue. Okay, so the ZIF64 is here, and I have the CPU, the PLA, and the VIC-2 in this board. These are the ones that were in this. I've moved them all 3 over. Now remember, I've tested all 3 of these chips independently of each other in this board, and they're working. But I haven't tried them all together. So the dead test is in here, all 3 of these are in here, the rest of the chips are still in here. Let's turn this on, and let's see if these 3 chips are working perfectly in this machine, or if that problem... Oh, wait, look. Something's definitely wrong. Like the top of the letters are cut off here. Instead of saying okay, it says GC. In fact, the text is all kind of weird. So something's going on with these 3 chips. Now, which is the one? Let's just try switching these out one by one. So we'll take the VIC out. I'll put this VIC in here. Let's see if that changes anything. Now remember, I couldn't test this VIC in the other one because this heatsink hits the cage. And look, it's correct now, it's working. That's weird because I tried this in this machine, this chip, and it was fine. So let me switch back to the chip that might be faulty, maybe. Let's turn it on. Actually, you know what? To make this quicker, let's see what it looks like without the dead test in there. Let's see how this looks with just the regular kernel. Okay, so that's definitely screwed up. Text is messed up and everything. Let me take out the CPU and switch back to the original CPU from this machine. Okay, that's not working at all. So that's weird. Let's take the PLA out and switch to my other PLA. Wait a second, now that's not working either. Okay, let's put back my original CPU. I'm quite confused here because I definitely tried this VIC-2 in this machine and it was working fine. Look, it's working. So wait, what's the combination going on here? Is it the PLA? Is the PLA weak or marginal or something? Let's try this. No, that's working now. Oh, this is so confusing. So we'll keep that PLA in there and let's move back to the original CPU. Well, the original as in the one from the other machine. So there it is. And that's, wait a second, and now that's working. Okay, never mind. I think that was just a red herring. I must have had one of the chips not seated correctly. Wait, now we're getting a black screen. Oh, what's happening here? Could be the legs. You know what I'm thinking, actually? I think the legs on these ICs are a little corroded. And I think that's basically making them not make good contact with these ZIF sockets. ZIF sockets are pretty good normally. Okay, it's fine. Okay, so there's no actual problem with these three chips. I mean, they're working fully in this machine. It's just that the legs are a little corroded or not very clean, so they weren't making good contact. So that's all that corruption was going on, was purely just bad contact. Could that be the problem in the other one? I don't think it could be, because I've taken them in and out and nothing has changed at all. Of course, a little Deoxit can't hurt, so why don't I put Deoxit in here? And the original chips are back in. Let's turn that on. I thought I was onto something, some kind of weird intermittent problem with these three chips. And no, look, exactly the same corruption, exactly the same as before. Off camera, I went ahead and I tested the ROM chips and the two 6526s in the ZIF machine, just to make sure that it would power up with those in the machine, and it appeared to work fine. I didn't use the diagnostic harness, so I'm not totally sure these 6526s work perfectly, but they definitely don't cause the machine not to boot. So I put those back in here. All the original chips are back in. Let's see how this behaves without any diagnostic cartridge in here at all. And on my little note here, I didn't really specify. Okay, so we have a blue screen, so it's sort of running, but definitely not fully working. Let me put the dead test cartridge back in here. I just want to make sure that dead test looks the same with the same problems with these chips back in here. Okay, and it looks exactly the same, so I'm not going to let that run any further. I'm going to change this to run my other diagnostics 2 and 5. This is the diagnostic ROM that is a bit more thorough. It tests everything. It needs the harness for full test, but you have to have working ROM chips for the other diagnostic test to work, which is why dead test is good, because you can pull these out and it will run. But the other one, if there's a problem with your ROM chips or something else on the bus, that will keep it from running altogether. And it does need working memory. So let's see if this works. Oh, hey, it's running. So I should have run this before, maybe. This might tell us a little bit more. It's a much more thorough test. So, okay. RAM test 1 is what this should say, and it says bad. And I gotta go look up which chip this is. It's not U20, but it says bad. And there's normally a RAM test 2, but it didn't even run it because this first one was bad. It's running through the rest of this stuff, and these are bad because the harness is not connected, and these down here. So we can ignore that, ignore everything here. But the color RAM worked, the ROMs worked, it's just RAM test. So I'm pretty sure that this chip here is U21, it's not 20. For whatever reason, each one of these is one less than it should be, which is indicative because the screen memory is holding the text you're seeing here. And when it's trying to display a 1, if that RAM chip is bad and say that bit is bad, it might create a bit error, which might make it show 0. I'm doing a voiceover while editing. I wanted to point out the text corruption on this screen here. You can actually kind of tell which RAM chip is bad. Notice that in some spots it says NJ instead of OK, and also where it says bad, instead of an A, there's an @ symbol. And in other circumstances, the word bad has a C instead of a B, so CAD. When characters in screen memory are offset by 1, either up or down, that gives you the impression that the problem is data bit 0, because that would change those values by 1. And data bit 0 on RAM, that's U21. Anyhow, this is U21 right here. I didn't talk about the RAM because it's MOSTEC memory. It is not MT. If it was MT, I would have immediately been suspecting the RAM. So is that chip hotter than the rest? It's not at all. These chips, if they're barely even warm at all. but it's telling me that this is bad, so I guess I'm gonna pull it out. All right, there is the socket install. Here's the bad chip that I took out. Well, hopefully bad. I mean, I am 0 for 3 on these other chips, so goes without saying that this RAM chip is probably good as well. Let me just pop in a known good chip. I will steal it off of the ZIF board here. I have one right here. There we have it, one TI chip installed. I'm gonna keep the diagnostic cartridge out of the machine for now. Let's just turn it on as it is right here and see if this fixes it, and that was the problem all along. Here we go. Would you look at that? That was the problem all along. I can't even believe it. It's working. Why did dead test lie and say that the RAM test was all good? Let me put the dead test back in here. We'll run it, and I want to show everyone that without a corrupted screen, that it did do a RAM test. The dead test does a full RAM test, and it said it was good. It said it was good, and it was lying. So there it is, dead test working, no issues. It tests the 0 page, which is part of memory. It tests the stack page, which is also part of RAM. And here it does, we saw it doing this. It's doing the screen RAM test, which it passed before. RAM test, yeah, it does do a RAM test, and it says okay. And it was passing all the tests before. So dead test, definitely don't trust it. It gives you false results sometimes, and in this case, it was giving me a false positive that all the RAM was good. Is that a false positive? Or maybe it's a false negative. It might have been, maybe that's a false negative in that it said the RAM was good, but the reality was it was actually bad. Maybe it was a false negative. Okay, well, whatever, semantics. It said the RAM was good when the reality it wasn't. So I've switched this over to the other diagnostic ROM now, the one that needs the harness. And this is where it gave us a more conclusive RAM test, no screen corruption. And this is the one that there, CU21 is the one I switched out. Clearly that's it, yeah, RAM test 1, RAM test 2. If I had only run this cartridge from the start, then I would have actually avoided all of that troubleshooting where I socketed those 3 chips erroneously. Yep, okay, so the RAM tests work, PLA test is good. I'm gonna plug the test harness in so we can get a full test on all components of this board. All right, well, actually, now it just shows the control port being bad, which is one of the joystick ports. Maybe I have these plugged in wrong. Let me just double check that these are right. Control port 2, control port 2. So those are connected correctly, but we're still seeing a bad there. So I think at this point, it's a red herring that I'm gonna plug in my Easy Flash, and I'll run the joystick tests, and I have a feeling both controller ports are actually gonna work. All right, there's the Easy Flash. Oh yes, I forgot. Easy Flash doesn't work on Rev A boards. There's some mod you have to do to these to make them work. Well, at the minimum, I am able to push up and down with the joystick and it's working fine. And if I push the fire button, okay, well then that causes a glitch, but that is a known problem and I've encountered it before and I forgot what the fix is. Let me boot off my SDIEC with the keyboard connected, and that way I can run the joystick tests without the Easy Flash. I've loaded up Pad Switcher 64. If I hit fire, this is a standard joystick test. Okay, so far so good. Everything is working fine on control port 2. Switching to control port 1, up, down, left, right, fire. Yeah, everything is fine. So like I said, the failure that was showing up in there is not real. Oh, although maybe it has to do with the paddles not working because of course the SID's not installed and the SID's required for paddles. Okay, that could have been it. So in other words, this thing is passing all of its tests. All right, so this machine is fixed. I didn't write this earlier, but this was number 1. And I am just gonna write what was wrong here. Bad RAM at U21. And I'm just gonna write 3/20/21 there, just so I know the date. So there we have it, a fixed Commodore 64 sent in by Mike. Thank you very much, Mike, for that. I'm not gonna test this keyboard out. It probably is gonna have issues, need to be taken apart and cleaned. Clearly needs new stems, it needs new keys. All these keys are so yellowed though, so maybe it's worth just leaving them that way, just giving this thing a clean, I don't know. Either way, that's gonna be an easy fix, not a problem. But this motherboard sent me down wild goose chases because the dead test cartridge gave me a false reading that said the RAM was good when in reality it wasn't. So learn from my mistakes. You need to test all the diagnostics you can first, because if I had just run the regular diagnostic early on, I would have seen that RAM chip were bad and I would have replaced that without replacing these 3 other chips. Anyways, you live and learn. This chip here needs to get an X drawn on it and thrown into the very overfilled bad parts bin. Die, chip, die. There we go. All right, so that's gonna be it for the first video in the Repair-a-thon. It was not an easy fix like I thought it was gonna be. It stumped me. Anyhow, so I hope you enjoyed this video. If you did, I'd appreciate a thumbs up. If you didn't, you know all that stuff to do. You can thumbs down, whatever, subscribe if you don't mind. And of course, there'll be more Repair-a-thon videos coming soon because there's still 4 other Commodore 64s that I think don't work. Although some of them may work. I can't remember if I've tested all of those. So anyhow, on to the next video. So I'll see you there. Stay healthy, stay safe, and I'll see you next time. Goodbye.